All right, I hope this works. So let's see. Am I live? Is it everything working or? Let's see. I'm not sure if even stuff works. All right. Is the video okay or is it slow? Having any issues? Sound okay? Sound check. 1 1 1 2 3. Is the volume okay? Last time I did a live stream was very long time ago, so a lot of stuff in software changed, and I'm not sure if all is good. All right. So today idea for this live stream is to work on some electronic repair stuff and hopefully get some progress and don't break something in progress. Okay. I had a little bit of a problem with my equipment yesterday, and that's part of the reason why today live stream start late. So first I would like to show you what we're going to do, and we'll go from there. Okay, so as some might know from my website, I was working on the building precision calibrators, and I had finished one of those before, like this one. This is Fluke 5700 series calibrator. Can source stable voltages, resistances, and currents. So the main purpose of instrument like that is to test different multimeters and different measurement devices and to check if they are in spec, and if not, help them to adjust and calibrate. So for example, I can show when you go to the store and buy a Fluke multimeter like this one. This is Fluke 87. Like you can see it's pretty normal meter, and when you measure like voltages, how do you know that it's telling you the truth? So for that, the manufacturer will calibrate all the meters when they are on the factory floor, and if you read the manual, you will see like the accuracy specifications and voltage ranges and parameters like the meter can measure. So how do factory calibrate them? How do they test that they meet all the required parameters? Well, they use calibrators similar to this 5700 series or 5500 series, which is more common for the handheld meters like this 87. So they connect the calibrator to the Fluke input, and I can demonstrate exactly that. If I can find the cable. Give me just a second. Okay, I think this will work. So this is cable with the dual banana. I can show you right there. And then it have the copper spade lugs that connect to a calibrator. So let's do that. And then we connect output of the calibrator to our meter input. So perhaps I should zoom in so you can see what's going on. Okay. So we can enter the value we want to test and output, and then we check our meter. So, and using the multifunction calibrator have a benefit that you can source many different signals, many different voltages, and test pretty much every range and every function of your device under test, like this meter, and make sure they all meet specifications. So this is 1 volt, I can do 10 volts, I can do 20 volts, so even can do 1, 2, 3, 4, 5 volts. As you can see, this meter is showing correct values, and indeed it's in specifications. We can also do the same for resistance. Let's say 1 kilo ohm. And there is our 1 kilo ohm. So, but today we will not be talking about calibrations as is, but actually what's going on inside of these heavy and expensive boxes and how to make one. And for that, I'm going to show you different modules and different bits and pieces that I used to build this instrument. All right, let's go. I'm going to collect all the parts from everywhere around. So we will start with the motherboard. So there are 2 motherboards because this is isolated instrument and it have completely floating output. So there are earth reference part, which have all the digital stuff like processor, control circuitry, and there is analog floating part. Originally I was just buying spare parts for this unit, but after some point I happened to have enough of them to build the second calibrator. So instead of just having them collecting dust on the shelf, I decided, well, why not to go ahead and build 2 calibrators instead of 1. So here you can see this is a motherboard, and there are DIN connectors like these long ones, which allow the installation of all the different boards for different functions. And then This board right here is CPU board. And I can bring the rest of the boards. We will work today and test some and fix some, and that's the idea. If anybody have a question or any comments, feel free to put them in the chat box and I'll check and reply. There are total 23 or 24 boards, if I remember correctly, in the calibrator like that. So it's quite a beast. But today we will work only on some of them. I still have 2 boards incoming on a couple days from now. It should be outguard power supply board, which plugs in here, and the rear interface board, which have GPIB interface, interconnect interface for the amplifiers, and some additional circuitry. Do I know which boards are broken, or is it going to be a surprise? Well, I bought most of the boards on eBay, and I assume they all broken, unless I test them and prove them otherwise. But actually I already did little of work before this video, so I know that some boards are working. For example, this power supply board. This is original board I used in that calibrator. By the way, the calibrator we are trying to build is Fluke 5700A, and it's essentially the very same model as this 5720, just have less specified parts. And as you can see, this board was already repaired before. There was a burn damage in this area, so I had to cut the PCB out and drill some holes and do some jump wires. But this is completely functional board. And most of these boards, as the calibrator, they are designed in 1989, 1990s. So it's not a new instrument. You can see all the components are through hole, none of this SMD stuff we are used to see today. But nevertheless, there is very much no replacement for these calibrators, and they are used for all around the world to do the calibrations and precision instrumentation testing. Today, the replacement model for these calibrators is 5730A. You can go to the Fluke website and find information about it. But pretty much most of the specs are same as 5720A, just updated for the modern components and new fancy LCD front panel, but essentially it's the same thing. Alright, so today I want to work on these 2 motherboards, make sure they are okay, because I can show you this board had a better days. It's a very large board. So you have the mains input, power from input go here, and the big transformer right here. And this board had a bit of explosion happened before. As you can see, there was some fire damage, and this is 6-layer board. So there was some some bad stuff happened here. And then these jump wires, I received this board as is, so this is not my work, but I'll have to check. These switches, they select if it's 110 volt input or 220 or 100, depends on what country you are in. I checked the fuse is okay, and this is the power switch. So before we start doing any advanced testing, we have to make sure this board is okay and repair whatever is needed. And that's it. And then I can show you the case, which sits right over there. That is the, well, most of the chassis. You can see there is a very heavy and big transformer here. It's fully shielded, have many different connections because the calibrator can source up to 1000 volts, and you need to provide a lot of different voltages for all the different functions. So I don't have all the parts for the case. I don't have this rear panel, so I'll have to design that in order for the metalwork fab. And then for the front, I actually do have the front panel, but I will be replacing it. Let me show you the old one. Here it is. So that's the front panel. You can see it's pretty much same as that unit, but it's have a model label. It's 5700A. The difference between 5700A and 5720 is some parts are selected for better performance, and also there are updates for the circuitry for better reliability. So this is just a front panel. It doesn't have any PCB which usually installs in here. It's the display board with large vacuum fluorescent displays, low thermal posts. It's important to use only copper connectors so the microvolt accuracy can be maintained. You can see all the old posts, and then I installed the new one just to show you the difference. And this front panel had a better days, but it doesn't matter because I have a brand new one which will be arriving sometime later. This is a low priority item because once I have everything else working, it will be trivial to replace the front panel. All right. So where do we start? I think we can start from up. Checking this board and figuring out what's going on in here. And this board we actually don't need. What we do need is the service manual, which I have. It's a quite heavy book. Here is the service manual. All right. And it's little bit thick. There are a lot of pages. Back in the days, they were doing really nice service manuals with theory of operation, description of the parts and circuits used, and even full schematics. Unfortunately, modern equipment rarely come with such comprehensive service information. So, I'll zoom in, show you some parts. There you go. So as you can see, the date is February 1990. It's pretty old. And this is how it looks like. Look at this. Just the specifications alone for the instrument like that go like on 10 plus pages. Theory of operation. And then it explains everything beautifully. Even have this nice A3 format pages which show you some parts of the schematics right here in the theory section, so can explain to you in nice and clear detail. When I was building my original calibrator here, this was my basically daily book, and I had to read through it multiple times. Section 3, calibration and verification of the calibrator. Shows you how to calibrate this. It's quite lengthy piece. Section 4, maintenance. It's also quite handy. But what we're actually going after here today is schematic diagrams. Basically half of the manual is all A3 format schematics. So this is front panel. We are not interested in front panel at this moment. What we are interested is A3 and A4 motherboards. And it's also very nice to remove the page you want, and then so you can work without taking all the manual with you. So here's the main board. We don't need this page now. Let's go back to A4, assembly A4. Disassembly. So let me take a close up on this. Maybe I should change the lens. Let's do that. I'm using DSLR for the capture. So getting the camera for the live streams would be a better idea. Perhaps for some other day. So hopefully you can see, this is the part of the circuit that shows the mains connection, and that's what we will troubleshoot right now. Let me get this page out. And also I need this page, and I think that's it. We can get this out of the way. We don't need this motherboard for time being, so I'll take it out. Okay. I'm not sure if you can see this, but is the video okay? There was a question what brand of relays they use for the critical signals. Well, there are different relays, most of them GS2E and DS4E series, but some of the critical areas like high ohm resistance output use Koto relay. And also there are 3 custom relays in the mainboard that connect or disconnect the front terminals from the internal circuitry of the calibrator. Because the calibrator can stand by, means that all the inputs are disconnected, or it can be operational, which means output is present and live. All right. So what I'll do now is basically check that this board and all the connections are correct and matching the schematics. What I want also to check is if there is any internal layer damage, and if there is, then I'll need to drill that out, because carbonized FR4 material is conductive, and we definitely don't want to have mains voltages to be leaking all over the joint. So I'll need to have a flashlight for that. Oh boy. Well, I can see there was some damage. Just shining light through the board to see what's going on. I think I'll cut some piece of it. You can see there was, it's hard to show. Let me turn off one of the lights. So there are inner traces and this wiring around, because actually a few traces was damaged in this area, and that's why the previous owner jump wired these connections. Well, the wires probably will be okay, because the traces on the PCB, they aren't thicker. So the calibrator doesn't output a lot of power, but it's all linear, so there is no single switch in power supply. Well, maybe some auxiliary ones, but most of the circuitry in the calibrator is analog linear design, and it takes quite a bit of power, but not too much. I think it's about 100 watts total. But I definitely don't like that black stuff over there. I want to cut basically all this section out. Guess we can do that. And how do we do that? Well, slow and careful, I guess. I'm looking for stuff. Cutting tools. But before we go dirty, we will draw the connections. Up. Now we'll use our trusty Fluke 87 and do some beeping. I guess if I'll go to Dremelin parts, then I'll have to mute the sound, or you all guys will hate it. Alright. Yeah, I'll probably take out the voltage switches because they are blocking a lot of area, and I want to clearly see all the stuff behind. So I can see there is a trace going here and here. Okay, that one is okay. And there and there. I'll just hand draw the part. 1, 2, 3. Всем русскоговорящим привет. So this is A4. And the switch designators, let's check them. Alright, switch 2, this is bottom view, switch 3, switch 4, and that's the power switch. There is a move. Okay. Oops, this one goes over there. This one goes this one here. The power goes to the fuse. I checked the fuse before. Fuse is okay. Let's remove. Okay. Okay. Time for some soldering action. I think that will be all right. Oh. So move these wires. Soldering job by the previous owner was a bit how you're doing. Definitely not to my standards. see. This video is okay? Let's see if this method works. All right. When I was building the first calibrator, I was thinking to design this board myself because I wasn't sure I was able to source it. But with help of friends, I was managed to get the original board. Technically, it's not difficult, or there is nothing advanced in this board, but it's tedious because it has 6 layers, large size, and it wouldn't be cheap. I'm actually think we can have a short break, and I can show you exactly more details about the calibrator. When I was building my first one, I tried to document as much as I could. First, because I was concerned I would forget things, and the second is if I would need service information, I would have a reference. Also, doing the project like this, repairing old but high-end equipment, is a great learning experience, as you can learn quite a bit of things. Don't get discouraged by the age of the instrument like this. All the concepts and all the ideas, they are still valid today, even in modern the design and electronics. Of course, it's not cheap to go and just start building calibrators, so definitely not for everyone. Okay, my site loaded, so I can put a link in the chat box where you can see the draft of the first calibrator project. So you can see a lot of photos and links to the service manual in electronics forums and a bunch of notes I took back in the time when I was doing the first one. Okay, one switch is almost out. Just need to get this stubborn pin out. Maybe. Hello, Todd. How you doing? Todd is a respected contributor at XDevs, and we should welcome him. Everybody, welcome Todd. Without his help, I think this calibrators projects wouldn't be possible. All right. We just wiggle, and she'll come right off. Maybe we'll wiggle more angry. Ah, there it is. It's a little bit dirty and filthy, but I think she'll be all right. I think I'll need to remove the next one as well. And then we can proceed with the cutting. Also, if you are looking for more information about projects like this, you can stop by on the EEV blog forum, and especially in the metrology section, we usually have a lot of interesting discussions about high-end instruments like this one and many others. I am also an active contributor there, trying to give back to community what I learned as well back in the days when I was just playing with the ideas of having my own calibrator at home, and now I'm building two. As some I already guessed, I don't have the vacuum desoldering gun, so I have to use this barbarian solder wick method. But it actually works quite nice for me. I like it. I don't do this very often, so I think it's okay. It's also a little bit of fun to see the solder to be sucked into the copper mesh. Like, and it's Gunsky. I hope there is no problems with the video, because I get these error messages from the YouTube thing showing that I have unstable internet connection, which is quite possible. Internet in Taiwan here is not a super speed, but yes, it works when it works. Come on. There is always one stubborn pin that doesn't want to free itself. Let's wiggle, wiggle. Okay, 3 pins are stuck, but we can deal with that. Oh yeah, there we go. Little bit of help and she's out. It's another filter switch. And now we can shine some light. Oh yeah, now you can see where is the damage area, that black spot. That have to go. Also there is a bit of the black spot on that one, so I guess I need to remove the switch as well. Alright, let's do that. My goal for today's live stream is actually fix this board and do some first power on with the transformer attached, so we can measure the AC voltages from the transformer and confirm that the transformer is okay. Because transformer is one of the other very expensive and custom parts used in this calibrator. It's not the part you can buy off the shelf. And I would like to know that it's okay before I start plugging those rare and expensive boards. Today chat box is quiet. This is because everybody is terrified. I know probably the time of this live stream is not very convenient for most of the viewers from Europe, for example, because of the time zones. As you might know, Taiwan is GMT plus. Oh, I guess battery died in the camera, but I'm prepared. I have 6 more batteries to go. My old DSLR isn't very power efficient in terms of video, so stay tuned. Okay, I think we should be back. And guess what? Just get a notification of donation received at xdevs.com. So thank you for donation. I'll use it for more calibrator repair projects. This is almost done. You can feel it when the pin is free. Also, it's important not to put any pressure, otherwise you may damage the PCB pad, and we don't want to do that. So you just gently put the wick on the pad and heat everything up and see the solder to be sucked into the copper. That's the idea of this. That run reference? What that run reference? I don't know what Todd is talking about. Don't have any references here. Want to do a tear down on the Detron multimeter? No, but I guess I don't have one yet. That's the project to come. Okay, I think we're almost done. Oops. That's exactly what shouldn't happen. I think she's going out. Wiggle, wiggle, and we are out. Hello, David. Nice to see you stop by. David is another very valued contributor to xdevs.com. Thank you, David. Let's all welcome David. All right. Let's get some film and let's get back to dirty work. Move this out of the way for now. Don't want to have the PCB particles flying all around the place, just have it a little bit contained. Alright. My plan is to do some of the cutting. So I guess I'll mute the sound. What you guys say? And do some butchery. Hope this is a good angle. All right, let's do this. Maybe I'll just mute it real bad. How about this? Okay, let's see what we have done. Okay, so this is the burn trace, and that's the delaminated PCB material. I can show the close-up. Let's change the lens. There we go. Oh, hope you can see. What the hell happened here? Doesn't look too bad. Think I can use the end mill and remove all that black stuff. Looks much better now. Alright, looks much better now. So I still need to remove that black spot, but we're getting there. Sorry, I forgot to quiet the sound. Now the second area is right there. Oh. Almost done. Okay. Okay, I think I'm done with battery. Let me show you the overview. Let's get this out. Check, check. Audio. Doesn't look too bad. Boop. Ouch. Need to be careful with all these sticking pins. I don't really care about much about epoxy. This thing, maybe some other day. Definitely not today. All right. Doesn't look too bad. So what we need to do is to restore the connections. Let's see, so input switch. Basically I'll just trace all the connections. Let me I have printed schematic somewhere, so we can draw on that, if I can find it. Must be somewhere. Must be somewhere. I know where it is. Whoa. There are a lot of pages of the schematics. And I'm pretty sure the page we are looking for isn't here. Ah, maybe it is. Here's the A4, A3, A3 again. You can see there are a lot of notes. No. Oh well. I guess I don't really care, and we can draw on this one. Maybe I should turn it upside down. So all the electrons stay in place. Our good old trusty 87 going to save the world again. All right. By the way, a little trick, like if you use continuity in that traditional mode in the diet, you can see there is a little bit of a delay. See? Doesn't really beep if you do a real fast connection. You need to wait like a half a second, then it beeps. But if you use ohms mode and use beeper mode, then it's instant. Just a little trick, maybe some of you don't know it. 87 in this mode is actually one of the fastest meter on the market for the beeper. So let's check, this is our input connector, and we will go from it and trace all the way around to the end. Pin 1 to pin 1. Okay, I guess that is pin 1. Pin 2 should be open. Pin 3 is neutral, pin 3 is ground, that is correct, and pin 4, pin 5 go to the other end of the switch. Let's switch is on. Okay, switch is correct. All right. Shield is okay. Switch is okay. Now we go to the fuse. So this trace should go all around to the fuse. I think I can reuse the existing wire and go it all around. Or maybe I use a new wire because I need a little bit longer path. Now if I can find my wire stripper, that would be nice. right. Let's check this connection. Alrighty. And I guess we'll have to do like that a couple times. Now our fuse connects to MOV. Yes. And then from MOV to the switch 3 and switch 2. We can also check. Okay, there is no other points there. Like so. All right. This is the second part. One, two. I wish they would have a pin 1 key on these switches. Oh, there is no key. So I guess we'll have to figure out by ourselves what's the pin numbering. Maybe 1, 2, 3, 4, 5, 6. Let's check this theory. And that is switch 2. Not really. Two and two. That theory doesn't hold. 1, 2, 3, 4, 5, 6. Yeah, I think that's it. 1.4. 3. Yeah, I think this is it. This is pin 3. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Where's my green pen? I lost the pen! Help! Oh, there it is. This is okay. Now, pin 3. This is okay. And pin 6 goes to this point. I know this is probably very boring, but that's the nature of the live stream. There is no cutting out anything. So you are hearing me in this, meaning the same as doing the repair live with all its upside downs and positive sides. I don't know what the hell I'm talking right now. It is 11 p.m. here in Taiwan. And we are just started. If anybody alive, leave the comment in the chat box. I'll just tap a little bit. All right, thank you. Blink, where are you from? What's the time zone? Well, yeah, I think I need to have something to hold these wires down. Oh, UK. Welcome to everybody from UK. I think I also need a connection right there. This will be a little bit tricky. Oops. Well. Yeah, I guess it's okay. Do you want to have a closer up? Like I can change to the macro lens. You will be able to see better in detail. Should we change to the macro or leave as it is for the camera angle? What do you guys say? All right, I'll leave as it is. Little patch wire. I don't want to put the switches just now because then I'll not be able to see what's going on. I mean, we're not able to shine the light. Hello, Nick. So, pin 6, pin 2. That's all connection after the fuse. All right. Now pin 5 to pin 5. This is okay. I guess it goes on that inside layer, which I didn't cut through yet. So that is fine. And pin 2 to pin 2 of the switch 4, this one. Pin 2 to pin 2. Can you hear the relays clicking? I started the self-test on the calibrator because I had some issues with it yesterday and some failure, which we'll talk about some next time. So this is connection between switch 2 and switch 4 for pin 2 and pin 2. So switch 2 is done. Let's check other connections. So switch 4 pin 5 to move, that is okay. Switch 4 pins 4 and 6. That is not okay. Pin 4 is okay. It goes here and goes over there. Then switch 4 pin 1 I think is okay as well. It looks like so. Switch 4 pin 3. Switch 3 pin 1. That is not okay. Pin 3 I think is okay. And switch 3 pin 4 is okay. And switch 3 pin 6 is okay as well. So I need to fix switch 3 pin 1 to 108A, connectors J11 on page 2. Let's find page 2. Is the second page here? No. I think here it is. Yes. So it connects to this connector, J11. So that's what we will check. And J11 goes to transformer, this guy. So this is pin 1, pin 12. Let's go and verify all these connections. So switch 3 pin 1, this guy should connect to pin 2, no connection. Hello to Portugal, Alvaro. Okay. Pin 2. I wonder if so one of the options I could do, I need to connect this pin to this point. Let's check. I can run just a wire like so, or I can just run the wire like so. I think I'll do that instead. But I need a little bit more copper than that. Each. Let's fix that. Okay, that should do it. Basically, it's a trace from the, I believe, layer 4, which is essentially the same routing. And as you can see, the trace isn't very big. So that's why I don't use any thicker wire. It's not necessary. And here is our connection. It'll go just like that. Like a little hook. Hello, Cat87. We are not finishing anytime soon, so it's okay. For those who are joined, I'm fixing the motherboard for the Fluke 5700A precision calibrator, and this is a project I'm busy on for quite some time already, and I want to build one of these calibrators here at home. I bought this board as parts, and it had some burn damage, so now I need to fix it and test all the connections to ensure that it's all following schematics, and then we can do some power checks with the power transformer. This is a range switching circuitry for the different mains voltages, like 100 volts, 110, 220, 230, 90 volts, depends on the country. So here is our pin 1 connection from switch 3 to the Alright, this is okay. Now pin 6 connector from switch 4. Pin 6 connection from switch 4. It's signal called 0B, and it should connect to pin 11 on connector J11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there is a connection. So I guess we're done here. All should be good. Let me clean a mess a little. I want to touch on a few pins. And let's fix these wires a little bit. Maybe anybody have a suggestion on some epoxy, hopefully from DigiKey, which I can order to fix those traces. So now I need to put the switches back in, and I guess we can go ahead with some power tests. They're a little bit dirty and ugly. Maybe I'll have just a touch on them. I tried to buy the switches before, but I couldn't find the right angle version of them. So they are, let's see, ITW, US patent 4311885, 10 amp, for 125 volts, and 5 amp for 250 volts AC. And is it the model number? I'm not sure. It says SE1022 VDE. Let me Google that up. So ITW SE1022 VDE. Yeah, they are indeed. There is a first link to eBay for these puppies. Like this one. Well, I wouldn't be using hot glue for this purpose, because this is mains voltage live circuitry, and well, also the calibrator runs quite warm, and the hot glue wouldn't be a great idea here. What is UV glue? Is it just me, or DigiKey is really having network issues recently? I think a couple days ago I couldn't open DigiKey. Yeah, it doesn't open. Or is it just a Taiwan thing? The gray Taiwan firewall. Well, we don't have one yet, but you never know. Well, it opens on this computer. Let me try again. Well, these switches are not available from DigiKey, unfortunately. So I guess we'll have to use these old ones, and I want to test them anyway. Let's put these puppies back in. kind of dirty and filthy. Don't like that. See? That's what I'm talking about. Hello, A28B. Wonder if I can disassemble one. Do you guys think it's a good idea? Let's see. Yeah, it's probably wouldn't be such an easy task without destroying it, and I still need them. Let's get it's not that there is some crazy leakage requirements in this part of circuitry, but it's just spending so much effort and money on the building calibrator and skipping on them putting good switches. It's kind of how you're doing, so I guess I'll order the new switches and replace them sometime in the future. But for now, just for the quick power test, I'll just put these ones in. See? Oh, horrible. Horrible. Ooh. Oops. I think I need to clean up a few connections. Zoom out. Why you don't want to go in? What's wrong with you? Yeah. There is too much solder on one pin. Guess I'll have to reconnect this wire later. Oh yeah. I hear Todd making noises. I have the live feed from his camera 24/7. Okay, this should be good enough. All switches in place. Now we'll solder all pins. There we go. The reason why all these wires on the board, for those who just joined, is this board had some fire damage on inside layers, so I had cut through 3 layers. This is 6-layer PCB, So I had to cut through 3 layers and restore the broken connections using the PTFE insulated wire that you can see right on here. And this is again the outguard motherboard from Fluke 5700A calibrator. And the last pin. All right. Not too bad. Not too bad. I guess we can set everything up for the power test. How about that? You guys ready? Let's mess a little bit around. So this is a transformer schematics, which we will be using to verify the voltages. And here is the board. Make sure everything is clearly visible. There we go. So what I'll need to do is have the mains connector here, and then We'll put this board in the case, test with the transformer. So first I need to get the stuff organized. And the problem with that is if I just take the case, I can show you, because of this wall on the side, I don't have easy access to the connections. So, I guess we can just remove this frame and use it without the case. Well, I would use the Variac, but at this moment I don't have one. And I just lost a screw, which I actually need later. Give me a second. Oh boy. There it is. Okay. Oh boy. Also, I need this. I actually have at work access to AC source, so eventually I'll take it and test over all voltages, but that would be for some other day. Let's get this out. Somebody used wrong screws. That is definitely not the correct screw. All the threads are stripped. Oh well, that's what we get from buying the destroyed gear from the secondary market. All right. There we go. I'm trying. "41, 42B. You mean like that one sitting right over there?" For those who don't know, this instrument, 4142B, is the modular SMU mainframe, mostly targeted for semiconductor and other devices like parametric analysis, like I'm trying to remove the mains filter from the case, and it's bolted down real hard. So it's hard to say what is a good price because, well, the price vary a lot for this, and I paid for mine, for the mainframe itself, 220 USD or so, and it had just voltage source, this module 41424A. It's basically dual channel meter and dual channel voltage source up to 40 volts, and it had actually had two of these and one of these. This is 41421B SMU. And later on I bought 4 more modules, and I bought 4 41420A, 1, 2, 3. These are 1 amp 200 volt SMUs. They occupy 2 slots. And also I got some AFU units. And the total price of everything was close to like and spent project, and to show modules, I still have a few extra which I'll probably sell at some point. So here is the 41425. This is analog feedback module. I actually have 2 good worker ones. So here they are. I have 2 because actually one of them was coming with the SMU I wanted, and I really wanted just an SMU, but it came as a package. And also I have one of the SMU which some issues, but it triggers the self-test error. But output is there, so I'm not sure what's wrong with it, and because there is no schematics for any of this, well, I just left it as it is, and I already have 3 working ones, so I don't really care at that point. Okay. I hope that answers your question. They are actually quite nice units for like testing MOSFETs, transistors, and different op-amps and stuff like that. They have not a best performance like the modern equipment would have, but they are very capable. The only problem is that there is no, all the software for them is very old, and I basically just ignored all that and write my own Python scripts and control it using Raspberry Pi over GPIB. I hope that answers your question. Well, sorry about the lags, not much I can do about that. So this is what I was stealing from. It's some customized Fluke filter, which it's basically mains filter with common mode choke and with the output on the side, like that. Have the Fluke part number 775445. I guess we can look inside of it. Maybe there is some dead bug or some spider. Usually they are all molded up and sealed up. I'm not sure why this one have removable cover. Let's get this out of the way. Yeah, I wouldn't pay $1,500 unless you are really desperate for one of 4142Bs. Even if it would have all the modules, well, it's kind of a bit much. The benefit of the 4142B mainframe is that you can use it for quite low currents, and all the outputs are triaxial. I actually built a small box. Let me, if I can get it out. Oh. Yeah, so this is a box. It's a polycarbonate box, which connects to one of these heads. This is one of HP very expensive cables. All the triaxial ports from up to 5 SMUs and interlock. So the part number is 0804 of 85 61684, interconnect cable assembly. So it terminates to the 4 SMUs on the unit, and then I just use the triaxial connectors and build a box so I can connect. You can see some LEDs in there, so I can test. I was using this to match 2 JFETs together using 4 SMUs and the Python script. So it connects like so, just plugs right in, and there we go. The lowest current I was able to measure, like the low noise current, is around this is pretty. The lowest noise level was like 10 minus 13. So it's pretty amazing SMU. It can definitely go much lower current than, oh, battery dead. Definitely can go much lower current than the traditional Keithley 2400 series can do. So it's more in line of what Keithley 4200 and Keithley 2600 series SMUs. Well, this is all potted, so not much we can do about here, but I don't see any physical damage. Kind of cool. Looks like 2 chokes, couple resistors, some X caps, some black thing, and well, that's it. Probably if you try just to buy this filter part from Fluke directly, they will charge you for a couple $100. I'll just clean it up a little and she'll be all right. Or not. I guess we'll find out when I plug it in. Ooh. This panel will need some cleaning later. I think it looks like maybe mu metal, but I'm not sure. Probably not. Oh boy. It's a little cute filter. I know you guys thinking I'm trying to stall the moment when I plug that board in and blow everything up. So here is our transformer. There we go. And actually, I don't have much concerns about transformer because, well, because one of the other reasons, which I'm going to show you soon enough. Transformer is mounted on this very heavy steel frame, which is used as a basically case rigidity frame, and also it holds 2 fans, 92mm 24 volts fans that provide the cooling for the calibrator. So it's filthy and dirty. And the part number, for those playing at home, Fluke 813527. And I believe this one is made in 1991, if that is the date code, which I'm not sure. And give Give me a second. Now I don't know if this transformer from the case is good or not, so we'll have to verify that. But if it's dead, well, that's not a problem, because I have not one, but two. Look at that. Maybe this will be a project for the third calibrator? Well, I hope not. They are same part number, 813527. And this one, I know for sure is good. So that's our backup plan, if things goes wrong. All right. Yeah, with the high-end precision equipment, you indeed do want to have spares of spares of the spares. So let's get some foam. Because if you try to buy any of these from Fluke service, first they will probably not sell it to you. They will only deal with the big well-known names and people like that. But if they do sell you, they will quote you for the price where you will not be happy with. Anyway, so let's place all of this together and think how we'll connect it all. So yeah, that will not going to work. I need a flat surface somehow. Maybe I'll just use this foam and cut it a little. That should do it. All right. No metal parts around. And let's put the transformer on the board. It sits like that. Pretty much. So we'll just place it like so. This connector a little bit short. H. If I tilt it a little bit more, then she'll be all right. Okay, so let's plug all this stuff. And this is our mains, I believe. These connectors have different number of pins. Lucky for us. And the connector is too short, but that's not a problem. And this mains filter goes right in here. And let's get our good old Fluke 87. You can see the voltages, I hope. And power switch, it's all good. I think I need some small foamy piece. Alright, now we need to switch to the voltage 110 volts. That's what we have here in Taiwan, same as in US. And we can start some testing. Let's see the range. All right, we are plugged in. Let's get our schematics. Now, the good idea would be actually to check the resistances of all the windings of the transformer. But let's say I just have a lot of confidence and I'll just power it on. But I would definitely would not suggest you to do that if you are troubleshooting anything like this. So don't do this at home. Yeah, that should be okay. Also keep in mind that the voltages output from some of the windings are quite dangerous, well, and even lethal, like 50 volts AC and some high voltages like 428 AC or 220 volts AC. So this is definitely not a safe thing. Alright, so I hope I will not kill myself in process. And that's why I'm looking at everything right now, trying to check if there is any problem. I'm just checking something here. I'm just checking the manual what settings need to set for the rear 110 volt configuration. So just give me a second. Okay, so switch 2. Switch 3 should be dot, and then switch 2 and 4, no dot. Let's do that. Dot, no dot, no dot. Okay, I think that's it. So first voltage I would like to check is voltage for the transformer. Pin 1 and pin 5. Pin 1 and well pin 4. Yeah, pin 5. Okay, so everything is out of the way. Let's check the resistance. 2 ohms. And let's turn thing on. And nothing happens. Because the switch is off. Okay, here some buzzing. And it's 110 volts input. Nothing smells, nothing smokes. Let's check some of the output voltage. How about we check what is connector J13. J13, that's the digital board. So let's try 1.1 and 4. But before that, we check 7 and 11. This should be 110 as well. And it is. So let's do pin 1 and pin 2. This should be around 5 to 7 volts. Well, 5 AC, that's the name of the signal. So that is 8 volt AC. looks good. And that was not good. I think the fuse just killed itself. Let's check that. Houston, we have a problem. I heard zip, and then there is no voltage. That sounds like a dead fuse. And let me find the screwdriver. Screwdriver in this joint. All right. Yeah, the fuse is gone. And it's quite warm. No, it was not set to 230. The setting is correct. And anyway, even if it would be set on 230, then the voltage would be half of the output and everything would be okay, because the mains voltage here is 110, it's not 230. So I guess I'll need to find a replacement for this 520 fuse. The rating is there is no rating on it. I believe I have some spare fuses, but that's not going to work. Yeah, rating should be 3 amps. 3 amps for 110 volts and 1.5 amps for 250 volts. Let me look for the fuse now. And the fuse I removed from the calibrator didn't have any label on it other than 230 volts or 250 volts. Now the tricky part is to find a box with fuses. I'm sure I bought some before. And the question is where they are. I found some smaller ones. but that will not work. Okay. Let's find some fuse, shall we? Now you got to see the secret stash of X-Dev's parts. Some SMD fuse, the PCB fuse. That's not going to work. I don't think the fuse will be in the ESD bag, so we can roll all these shiny ones. Some random project boxes. Some round board mount fuses, and those will not work either. More SMD fuses. This is a connectors I bought before, but they are not the right angle. Ah, I see some fuse. 4 amps. Well, this is a bit too much. Size is correct, but these are not the right fuse rating. Let's look some more. Oh, 3 amps, 250 volts. Well, I guess this will work. So we have 10 more chances. All right. And actually I also need one of these. So, I was looking for this before. There's the thermocouple for the DMM. All right. Let's get back to work. Now the question is either we should try to find out what's wrong with this transformer or try the good one. To see maybe this transformer have the problem, and what you guys say? Should we try a different transformer? I guess I can go back and check some of the resistances. If I can find the page with the notes where I write them down. Or we can just compare resistances of this one to the other one. Because that will be definitely quicker than trying to find the 2-year-old notes. Yeah, I guess let's check the resistances. Unless we just plug the different one and try again. All right. Well, let's do some testing. Yeah, give me the cable. All right. Let's start with the primaries. And I'll go from there. Oh, okay. This is interesting. Now that's a quest. This transformer have 2 more pins. I'm not sure if you can see. Let me show you. I believe the angle here would be better. Where the camera goes. All right. So the connector, this one, this is from good transformer, and this one we just tried. Check this out. They are not the same. There are two extra pins, black wires, going back into the trafo. And I remember there was the newer board on my calibrator over there used also more pins, and this one was just a short, because the connector is 12 pins, not 14 pins like this. So I'm not sure what's the deal there, but I don't think that's what caused the problems, and that fuses. So let's go ahead and check 1, 2, 2, and first we know the reading. .48. Let's check on that one. About the same. .5 ohms. Now pin 3, 2 and 4, 2.62. And let's check on this one. It's about okay. 2.6. Then this two should be small resistance. 0.5. 0.4. Looks okay. Now this one and this one should be nothing. Isolated. Yeah, that is okay. .6, 2.6, 0.4. Looks okay. What's about the resistance to earth? Should be infinite. And it is. And check this one. You guys probably already all sleeping with this boring stuff. And resistance to earth. And let's check this 4 wire, 2 unknown wires. It's 0.2. Looks like almost like a short. Let's check the board resistance. There's nothing. Well, there is no short on this side. Let's check if the mauve is okay. think them all is okay. Let's put the fuse in and check the connection from mains. So the resistance between the pins is high. Let's check. So it connects pin 1, pin 2. Let's see again. Pin 2. No other connections. And pin 1, 2, 3, 4, 5, 6, 7, 8. Pin 8. That is correct. What is this? And then this one should pin 5. Yes. And pin 11. Yes. So there is no problem with this part and this part. We can check this resistor. It's R3. That's with the cap. And R4, 68 ohms, that's correct. And R2, what's the R2? I don't know. R2, 2 ohms. And R3, 2 ohms. That is all correct. Yes. Yes. Good morning, Steve. Well, oh well, let's go and check other windings. Because even if the primary is okay, if there is a short or dead secondary, that would cause a lot of draw from transformer, and well, that wouldn't be good. .053. Oh, 0.45. This is which one? P16? .3. Looks okay. Pin number 4 and number 5. What? Oh, there is nobody there. And pin number 6 and 8. 8 to 063, 062. That is okay. Let's check 13. So this is yeah. Is it like that? No. Zero 38. Same. 75 volts for the VFD drive. 26 ohms. It sounds about right. 24 ohms. 35 volts for the VFD as well, I think. It's 12 ohms and 13. Well, that's okay. And this is 12 volts. Yep, that is okay. So, okay, let's test the high voltage rails. And this is connector 15, this one. Let's check the whole winding. So that would be pin number 9 and pin and pin number 14. All right. Which one is 9? It's a little bit confusing. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the whole winding is 300 ohms, thereabout. Check on the 400 ohms. I think that is probably okay. Let's try 5. $66 and 7. How about here? 86 and 7. I think that's okay. This one is a little bit higher, but I don't think that's much of a problem. Let's test P14. One and 2. 1.4. 1.4. 0.49. I can just reach from here. Nope. .042. Let's and the blue and shiny is the guard. It's about the last ones. 233. 242. Let's check this one. 368. 350. Well, 3, 4. 3, 6. 1, 5. 3, 4. Let's check again. Well, doesn't look the transformer have any problem. Any ideas? Maybe the fuse was wrong. Maybe that was 250 volts, 1.5 amps fuse. And it blew because I'm using 110 volts, which should be 3 amp fuse. Because it didn't blow right away, it was working for like 10 seconds and then it blew. Any ideas, guys? Maybe I should set it to 115 volts instead of 110. Let's actually measure what's the mains voltage in here. Oh boy, measuring AC voltage on DC range, that wouldn't work. Well, it's 110 volts. So, and this is what the board is set to, I believe. Yes, it is. Let's check this filter maybe. Maybe it's a dodgy filter. Earth. Can use another filter, another of these. Yeah, it was buzzing a little, like faint buzz, but clearly audible. I can use one of these. This is a real expensive filter from Corcom, 3ZM4. Let's have the fuse and everything. So, or it could be a bad fuse and we can just try again. It's kind of not the way I like things to go. Blaming the fuse. Okay. Try again with another fuse. Well, okay. There is a note, and in schematic it says, let me show you. Transformer assembly, secondary voltages assume primary is 122 and secondary represent open circuit measurement. And there are a bunch of voltages everywhere. So I guess we can try again. All right. This should be 12 volts. Plug cables like so. And of course you can see nothing. Alright. Let's try again. $15.6. I don't hear any buzzing anymore. Should I let it run for a little bit? Also, I connected these two connectors. Let me show you. I had connected this one and this one. So let's check actually resistance on those pins. Maybe there is short in the board, which we don't know about. There should be no any shorts because this board doesn't have any boards plugged in. There is no power supply board and no CPU board. So this essentially should be everything up open circuit. And it indeed is. Don't see anything. Yeah, light bulb is a good idea, but I don't have any actually incandescent lamps to try that. Like you can really tell that I don't work with any mains power troubleshooting much, and usually dealing with mains here just goes to connecting the power supply to it, and that's it. I mostly focus on what comes out of the power supply, not before. Let's connect one of the high voltage coils and check that. PAHC1 and PAHC2. There should be 800 volts there, I believe. Or yes, there should be 800. 14 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 14. Let's hope this meter will not blow up. Like you don't want to touch anything here. And this should be, well, a lot of volts. 1000 volts. Yep, it's 920. There is no buzzing. Nothing happening. Well, you can kinda hear, but it's very faint. Like, I'm putting microphone right to the transformer. Most of the noise you hear is from calibrator right there. It's not from this thing. Well, doesn't blow up yet. Would be already done and gone if it would be running this long. So this fuse I can show you the old fuse. There. And let me catch up. So this was the original fuse, and the label just says 250 volts. And this one says Bussmann. Or no, not Bussmann. It's Bus MDO3. I believe 3 is 3 amps. But I don't know what's the deal here. Alright. I guess we can plug this stuff. And try again. I'll leave this connection to this high voltage winding connected to the meter, and connect low voltage signals. Back in. And then I'll connect this big one. There we go. And I guess we can try again. And 3, 2, 1. Don't hear any buzzing yet. It's all quiet. Voltage is there, 920 volts. I guess I'll let it run for a minute. Let's see if actually yeah, it does not go bad yet. Should we try and plug some boards? What you guys say? $920 volts. Fuse is not warm. I think it's all fine. So, because I don't have, I have the CPU board, but CPU board will not get any power unless we have the board next to it, which is power supply board. So that power supply board is in FedEx right now, and I should get it Monday, but it's not Monday yet. So the alternative is to take the board out of that calibrator and test with that board first. And the board in this calibrator is obviously all good and working, so there is no guessing if the board is bad or something, so should be all good and working. I think that's what we will do next. And I can plug this connector back in and plug the motherboard first to check that motherboard works too. I mean, then when it's all connected, it works together. And then we can put this stuff back into the case. Yeah, folks have, well, it's all there. Buried under the other stuff. So I guess let me change the lens and we go a little bit faster from now. I think this is another five hour long live stream or something like that. Let's change the lens. There we go. Now you can see everything. This is the lens I was using before. One of my fixer-uppers. It's Nikkor 2870 8.8 2.8. So we need to get this stuff out. Maybe it's a good idea to turn it off. And take So this is the power supply board. And that is the second, the CPU board. So I have the CPU board here. I don't need to take this one out of there. And this board goes right in here. But before that, we need to put some fans. Or actually we don't, because it will just give anyway error. Which is okay. Put some bumpers. Oh yeah. Okay, board is in. Let's put the CPU board in. Now I don't know that if the CPU is working or not. I didn't do any test with it. But it's digital board, so there is not much horribly wrong can go with it. So this is the CPU board. It's using Motorola 68000 CPU, revision J firmware. This is the SRAM. This is calibration ROM. This battery for RTC. And this board had some connector damage right over there. But all the pins are still there, so should be alright. And that's the money shot. 1987, made in USA. There are some pulls with the glue logic, so hopefully those are okay. Some SRAM chips. 5720 calibrator using the same board. They just have extra place for the firmware because the 5720 firmware is bigger, but it's essentially the same thing. Alright, let's plug it in. That's how these two boards go. Sorry about the focus. And now to make it even more exciting, I think we can connect the display board to see if it lights up. And I also want to monitor the high voltage still. So I'll just poke those probes. So let me get the display board out. That's the back of it. And this is the money shot. Some unobtainium display glass. Ooh, this one is good working board. So we want to be careful with it, and it plugs right like that. So I guess I first need to get some padding material. Keep it safe. That will do. Now I think I need to turn off one of the lights. And yeah, let's see if that does anything. Should we turn it on? Okay. Well, that was quick. And I guess something is not okay. Let's remove this first. Yeah, the thing is dead. Houston, we still have a problem. Let's check that we don't have mains in here. Yep, no mains. Let's keep the high voltage disconnected. Check the resistance. And zippity doodah. Guess we need to replace another fuse. And now that I remember, I also plugged high voltage connector back in the first test. So maybe there is something wrong with this main board, which loads the high voltage winding too much. Maybe. So let's try that theory and try without it. And we can check that fuse is probably dead again. Yep. Konski. Well, again, we have 8 more chances. I think this would be the last chance for today. Well, if somebody was hoping for an easy repair, well, this is the wrong channel. There are no easy repairs here. Okay, let's try again. So this should be in our 900 volts like we had before. And 3, 2, 1. Now let's plug the power supply board. I still keep this high voltage connector, not connected to anything. It goes to analog board anyway, so for this test we don't even need it. Now the power supply board is in. Let's have one of the fans just to see that we have juice. I'll just screw it down with one screw. The fan is powered from 24 volts, which come in from this power supply board. I guess I need 2 screws. Alright, fan is plugged in. Now we should hear some happy whir. 3, 2, 1. Okay. Let's put the CPU board. CPU board is in. They all look close, but they don't touch each other. Let's try again. CPU board is okay. Well, I don't know if it's okay, but it's the LED which shows reset is light up. And we have 920 volts on the high voltage. I guess we can try with the VFD board now. This is a good VFD board. I know it works. It was being used in that calibrator earlier this year. Well, yes. So I'm pretty sure about this display board condition. We don't expect any problems there. but I have, there we go. Display board is in. Let's see if something shows up. 3, 2, 1. Okay. Rear, okay. Well, that is pretty unhappy. Because there is no rear board. Hopefully you can see this. It's unhappy because there is no connection to the rear panel board, which I don't have now, and I'm not going to take that one apart from the good calibrator. Or there is actually a jumper which says, let me show you. I never tried that jumper before. See that? It's always in normal operation, which is position 1, 2. But there is also bypass mode. There is also one which says front panel, and it's next to that fan connector right there. So we can try to jump that. Maybe it will allow us to go past that error. Not that it matters much, because I'll get the rear board anyway soon enough. But it's not going to be on this live stream yet. Should we try that? Let me see if there is a short right now between pin 1 and 2. No. So I guess we can just use a tweezer and short it. It's just digital signal. There should be like 5 volts. I think there's just a pull up like that. Okay, I know this is less than optimal, but hey, let's try. Nope. Oh, I was hoping for something, but obviously if it doesn't have the UART, which plugs into connector right there, then nothing will happen. And well, I think that would be all for today. We got some progress, and we still need to troubleshoot that high voltage issue. But that will be for another day. I would like to say thank you for everyone staying for so long, and no, that was not the problem. And anyway, thanks everyone. That's it for today. Bye.